Hi, good afternoon, everyone. Welcome to this, our second segment of day two of our Easter CSEC camp workshop. So we want to thank those of you who have joined us for this session. And if you were in segment, it's better for you. But if you just got a chance to join us, we have an exciting sign up for you. Mathematics theme, and here we hail from Kingston and St. Andrew. We definitely will be having an interesting session, and to lead us through that session this afternoon, we have with us Mrs. Neva Cameron Edwards and Mrs. Karima Mundell Thomas. They will be taking you through the afternoon session, and we want to encourage the chance to open your microphone and to share. If you have not yet done so, you can call up a friend and share the link with them. Ask them to join because we all need to benefit from this session. So I am Faithlyn Williams, and I will be here with you this afternoon also. Over to Mrs. Cameron Edwards and Mrs. Mundell Thomas, who will take you through the rest of the afternoon.
Thank you
Over
very
to you,
much,
ladies.
Mrs. Williams. All right.
Come.
Okay, so we are seeing a few new faces, well, new names. Perhaps you renamed yourself. But welcome again to the afternoon session where we'll be having tutorials on statistics and probability. And as we go through the tutorials, feel free to ask questions so that we can clarify if there's anything that you did not understand this morning. We're able to use this session to flesh it out. But just as though this morning was a rich session, and based on the feedback, we would have garnered how this would have helped you to clear up some things and to get new understanding. This afternoon is promising to be the same. Okay, so Mrs. Mundell Thomas, let us begin.
All right, so for this afternoon, we have 4 questions that we want to take you through based on what was discussed this morning. Wherever we see a concept coming up that perhaps was not touched, we will pause and spend a little time discussing that concept. I hope that during the break, you did click on the link and saw these questions beforehand and made an attempt to solve the questions. All right, so our first question comes from May 2010 question paper, and it says that a class of 24 students threw the cricket ball at sports. The distance thrown by each student was measured to the nearest meter, and the results are shown below. So just as what we spoke about this morning, our very first question is giving us some raw data, and let's see what we are being asked to do with them. All right, so the first thing, we're asked to copy and complete the frequency table for the data shown. Now, this morning, we did encourage you to utilize a tally. However, for this question, no tally was there, but you can actually, do your own little tally to ensure that you don't make any minor or any mistakes at all. Let me put it that way. All right, so notice, as we discussed this morning, for this question, can anybody tell me quickly in the chat what type of frequency table do we have here based on our discussion this morning? Are we talking ungrouped? Are we talking grouped? What is it that we're seeing here? All right, and someone typed group. Beautiful. So for those of you who were not here, remember, for us to identify that, we can look at, in this case, the column that has our distances, and we notice that the distances are clustered together. All right, so we have distances 20 to 29 meters and so on. So we're asked to copy and complete. I do hope some persons got a chance to do this. And as we encouraged you this morning, you should try to cross out the numbers as you go along. We didn't do that here because you would have had the opportunity to do that during the break while working on the questions. So what would be our next distance? Following through with our interval, we had 20 to 29 meters, then we had 30 to 39 meters. What would be the other intervals that we need to complete the first column? You may type in the chat, or you can raise your hand and unmute once you're identified. All right, Dexton is quick out of the blocks. He has 40 to 49, beautiful. 50 to 59. I do believe there's one more. But you get the general idea. All right, so while they're typing that response, 60 to 69, awesome. All right, so we will be going through the data now to see how many of each value there are. All right, that should be pretty straightforward. So how many values for 40 to 49 are there? Did anyone here who was at the morning session, if you got a chance to do this question, you may type the answer that you got in the chat, or unmute and tell us, and we'll see if you are correct. So remember, this portion, we're going through the questions based on what was discussed earlier this morning. So did anyone get a frequency for 40 to 49 meters?
Well, I'm seeing where Dexton is saying 8 would be for the class interval 40 to 49. I'm seeing Johnson, Rakito saying. Okay.
All right, so let's see if they are correct, Mrs. Edwards. What do you know? And I'm pleased that they took our advice and decided to look at the questions a bit earlier so we can go through this session quite smoothly. All right, so we can bring up our other values. For 50 to 59, we had 6 of those in the data. And from 60 to 69, we only had 2 numbers in that category. Now, part B asks you to state the lower boundary. Notice the lower boundary of the class interval 20 to 29. Who can type in the chat or unmute and share with me what the lower boundary would be for the class interval 20 to 29 and how you got it? Anybody?
Not seeing anything in the chat as yet.
All right. Let me give a few more seconds. All right, so remember, guys, when we spoke about our boundary this morning, our lower boundary, we said that in order to find it, we could take off 0.5 from our lower limit. So
okay.
now that's all right, Dexton, very good.
Dexton is
wonderful.
Bringing it in.
Beautiful. So our class interval here is 20 to 29 meters. And so our lower limit is 20. So our lower boundary would be 0.5 less than that. All right. And for those who are not here, we are reminding you what the boundaries are. They are halfway marks between 2 consecutive class intervals, right? So that lower boundary would in fact be 19.5. Awesome job, Dexton. I'm really impressed, aren't you, Mrs. Cameron Edwards?
I am impressed, and I want the students to realize that all of what we discussed this morning is coming out right here in this past paper question. So when we're going to the tutorial, we want to see how the information, how it is linked. And sometimes the students see these questions, and as you said, I'm happy that they did not just only complete the frequency table, but they're answering the questions. So the terminologies that you heard this morning, we want to make sure you understand them so that when you see the questions, and these are just some 1 and 2 marks, so we don't want to lose them in the exam. We want to maximize to get all the possible scores that we can get.
Awesome. All right, so let's move to the other part of our question. Okay, now part C asks us to determine the number of students who threw the ball at distance recorded as 50 meters or more. So now we need to go to our table and we need to identify those students who scored 50 meters or more. Which class intervals should I be focusing on? Let me know, because there are 5 intervals there. Based on the question, which of the intervals should I be focusing on in order to get this information?
Miss, 50 to 59.
All right, that's the only one.
And 60 to 69, Miss.
All right, and I saw those responses in the chat. Awesome. So we're looking for 50 meters or more. So it means we must be looking for those students who threw the ball, I think it was, yes, the ball at a distance of 50 to 59, and also those who threw the ball at distance 60 to 69. Who can tell me in the chat how many students do we have that meet this criteria?
Right, I'm seeing the responses coming in. Kelly, Martin, they're all saying 8. Dexton, join them as well.
Good. So we had 6 students who threw the ball 50 to 59 meters. And of course, we had 2 students who threw the ball 60 to 69 meters. Great. I hope you guys are seeing that you are now equipped with information, with skills, with strategies to answer actual CSEC questions. All right.
And Mrs. Mono Thomas, before we get to the and go through, I want them to look at the inequality sign that's there. So even though the question said recorded a distance of 50 meters or more, what does that look like? What does the more or more? And exactly, so greater than and equal to. So if it is that you did not see the words in the exam, and sometimes they have this presentation to say, what if the question had said, determine the number of students who threw the ball at distance recorded as, but they're giving you the inequality sign in the exam, you will still know how to identify this from the table. So that's what I wanted to point out.
Awesome. Thank you, Mrs. Cameron Edwards. I think we can move to the next part of this question.
Yes, we can.
Oh, we're finished with question 1. Look at that. So we are now at question number 2. And this question comes to us from May 2013. All right. So we're given some scores. Notice the scores are obtained by 100 children in a competition, right? And the summary is given in the table. As with the previous example, we're noticing here that we have the data has been grouped into class intervals. Now, the first question says, state the modal class interval. And I do believe very close to the end of the session this morning, Mrs. Edwards, we spoke about modal class. So yes, this is a great opportunity for us to see what our students have learned. So which class would be the modal class? And I'm going to ask you why. How did you identify it?
When you're through it, go ahead.
20 to 29, miss. And the reason
Okay.
I'm choosing miss because 25 is the largest number. Yeah, miss, in the frequency column.
All right, I hear you. Does anyone else agree, disagree, have anything else to add to what was said?
I'm not seeing anything in the chat as yet.
All right. But you are indeed correct. We spoke about this morning. So remember now, when we're looking for our modal class interval, we first of all identify the highest frequency, because remember, that's what's going to tell us how many times the particular number or set of numbers occurred. So in this case, our highest frequency is 25. But remember, as we said this morning, we want the class interval. So we must see which set of scores or scores from which class interval occurred all of 25 times. And as we look at our table, we definitely see that it's 20 to 29. Awesome.
I'd like to ask a question, Mrs. Mundell-Thomas. So what is the
Sure.
class width? Just to make sure, what is the class width? Not seeing anybody type in the chat. Can you look at the intervals and tell us what is the width of the class? 0 to 9, 10 to 19. I've seen somebody answering. Thank you, Kelly. 10. Kelly wasn't talking so much this morning, but we're happy that Kelly was just one of those quiet participants making the notes. Destin is agreeing. Good. All right. And you know where I'm going with that, Mrs. Mundell-Thomas? Students, even if the question has not asked you for some things as yet, you begin to look at what is being done. You notice how the table is there, and as we are going to move on, you notice what the midpoint look like. You need to look at the question, see all the information that you can pull, so that when you're answering the questions, you can say, yes, I clearly understand what the question, I make sense of the problem. You know, math practice 1, understanding the problem and making sense of it. Okay, Mrs. Mundell-Thomas, over to you.
I'm happy that you asked about the class width, because it will help us even as we look at the midpoint that you mentioned. But let's see what was asked of us next. Part 2 of the question asks us to state the class interval in which a score of 19.4 would lie. And as I read this question, Mrs. Edwards, I remember the discussion we had this morning. So I want to see if you can tell me. I remember now, you're going to have to tell me why, so be prepared. How do you know in which class interval would a score of 19.4 lie? Who wants to tell me?
Miss, without an explanation, miss, but
All right, let's hear what you have.
Okay, go.
miss, you lie between 10 and 19, miss, are basically 20 to 29 on that one.
But you're going to have to nail down
You have
one.
to choose one.
You have to
Yeah.
choose.
So I go with 20 to 29, miss.
Okay. Anybody else?
All right, so I'm going to ask a question based on what we spoke about this morning. Are you able to identify the upper class boundary for 10 to 19, the score 10 to 19? What's the upper boundary there? We talked about boundary this morning, and I think we spoke about it in the earlier question 1. So the upper boundary for the class interval 10 to 19, what would that be? That may give you a hint. All right, I see Kelly typing in the chat, 19.5. Awesome. So remember this morning we spoke about the upper boundary being 0.5 more. So the previous question asked about lower boundary, but I just asked about the upper boundary, which is 0.5 more than the limit, the upper limit. So then if the class interval 10 to 19 has a boundary, an upper boundary of 19.5, where would 19.4 lie? And I see Kelly's answering in the chat. Does anyone else agree? She says, based on the 19.5, a score of 19.4 would lie in the interval 10 to 19. She's not sure, so she says she thinks that's it. Does anyone else agree, disagree, based on what we just identified to be the upper boundary?
Dexton is saying that he agrees with what was said.
All right, so next time you are unsure, so remember now, you may get a value that seemingly look like, I don't know where to put it. Is it in 10 to 19 or is it 20 to 29? Immediately think about your boundary, right? And that will help you to decide. So 19.4 has not yet reached the upper boundary, nor has it passed it. So it would still remain in the class interval 10 to 19. I hope that is clear. I think we can move on.
So miss.
Awesome,
So,
that's why we're here. I'm glad you saw it.
So Mr. Bailey, you started out right in terms of looking at the 19.4. I just want to add, I think someone said this morning, Mrs. Mundell Thomas, that they had used approximation. So when they looked at it and they were rounding, because 19.4 is less than the 19.5 halfway mark. So they would have placed it in that interval. So I'm not sure if that would also help Shamar in making the distinction as to which one of the class interval to actually put it in. All right.
Okay.
So indeed, 10 to 19 is correct.
All right, let's see what else was asked. All right, so part B, the first part, asks you to copy and complete the table. So we notice there are some missing class midpoints and there are some missing F multiplied by X, the product there. There are some missing products. Can anyone tell me the two values or the class midpoint, let me ask that way, the class midpoint for the interval 20 to 29. And someone else tell me the class midpoint for 30 to 39. You may use the chat or you can unmute. All right, so Dexton says 24.5. Awesome. For 20
how did you
to 29.
get that? May I just ask, Dexton, how did you get 24.5? What did you use to arrive at that answer? Yeah, 29, 20 plus 29, okay, and divided it by 2, all right?
That's one approach, and there's another way that you can double check. Just in case you made an error in a calculation, we gave another strategy that you could use to check if your class midpoint is correct. What else did we say this morning? Anyone remembers?
You can add 10 to the previous class midpoint. Where did that 10 come from?
Exactly.
Thank you, Rakito. And then Kelly comes in with the nice response.
Beautiful, because I was about to ask you, Mrs. Edwards, if it's always 10. Is it always 10 and you just add 10? Every question you see you're adding 10. So we have to be careful. So I like this phrasing, you add the class with to the 40.5. Awesome, awesome. So I do believe we can populate that column, Mrs. Edwards.
Yes, we can. So We already saw the calculation coming in terms of how to calculate the midpoint, just to refresh those persons who weren't here this morning. All right. But outside of that, we could use the class with as well. So there we have it.
All right, now there's another column, our F multiply X, and we had a little discussion this morning on how those values were obtained and what they meant. Can anybody remind us what that 36 in the first row for the class interval 0 to 9? Does anybody remember how we got that value there? How did that 36 come about?
It's times 8 times 4.5.
All right, so like you're asking me a question, but I know
No,
it's
Miss,
not.
me tell you.
Okay, thank you. Nice. I like
I
that
think
confidence
David,
right there. All
I
right.
So you multiplied the class midpoint by the frequency.
All right. Awesome. Great. So that 8 multiplied by 4.5, as was said earlier, would have given us our 36. And then we can, of course, complete the remaining multiplications.
all right, so let's
So
just
we
bring
can
in
populate,
these
right?
and just check
So
if you have these.
that's what I was about to say, right? So just
Okay.
double check to ensure you didn't make any, calculations that were incorrect. Any little error, your finger press something on the calculator that you didn't intend to. So just double check these. Now that 3,140, what does that represent? And how did we get that particular value? 3,140, right at the bottom of the column, F multiplied by X. Where did that come from and what does it mean?
Please repeat that question, Miss.
When you tally up the table,
What I mean by when we tally up the table?
total amount.
All right, I'll take that. So we're adding these values in the column, the 36, the 188.5, the 612.5, and so on. Those are the values that we're adding up. So this 3,140 actually represents the sum for all the scores that were in the data. So remember this morning we said that these little ones, the 36, was just the total for those scores between 0 to 9. I remember now this, well, the question will ask, so let me not preempt it. We'll speak to that in a moment. So the 188.5 would be the total for all the values that are in the interval 10 to 19 and so on. So that 3,140 would be our grand total for all the scores that were in the data. So question now, how am I going to calculate the mean? Somebody please tell me, whether in the chat or unmute, how do I now calculate the mean score? So I've completed the table. Kudos to us. Awesome job. Now we need the mean.
Mr. Divide it by the number, how much?
Yeah.
Divide it what? So you're going to have to give me the values so that
Yeah, I
we're
was
clear.
wondering. So I'm waiting too.
All right.
Mr. Divide like how much scores, the number of scores, out
So
of
can
the
you look,
total, to get add it up everything.
so when you look at the table, which number are you referring to when you say that? What total are you referring to?
Mr. You add up the number.
No, it's
See,
already total enough. So which one are the
yeah.
totals?
When I add up everything, the FX and that one, the total line there, this one. The
Okay.
Okay, so you refer to the
31.40.
3,000. Okay.
Okay.
All right. What am I going to do with that?
You're going to divide the number of scores into it.
What would that number be that I'm dividing into it? Tell me the number because I want to be sure. So I'm dividing 3,140 by what?
By 100.
100.
All right, so I'm a little unsure, but yes, that's actually what it means. So remember, normally when we have our raw data, we would have added up all the scores and we would count and see how many scores did we have. And if there were 10, we would divide by 10. In this case, we were told, first of all, that the scores were obtained by 100 children. So we already knew that there were 100 scores, but just in case we didn't even have that, as we discussed this morning, the total for our frequency column also gives us that information. So yes, you are indeed correct. Sum of the data, which we have to be 3,140, divided by the number of data points, in this case, it's 100. You may want to double check that answer that's coming in the chat. Maybe you did a little slightly in
31.4.
31.4 it is. All right, so let's double check that answer that came in the chat. Awesome. Great. We're on a roll. Moving on to the next part of the question. I do hope, though, that this is clear to you. And of course, remember that we are live on YouTube now. So after the session, feel free to go back to the channel. I do believe we'll post the link later on. You can actually go back to review the session and look back through what we have done or what we're doing this afternoon. All right, we can go ahead, Miss. Part C, and I almost spoke about it earlier, but I remembered it was coming. So explain why the value of the mean obtained is only an estimate of the true value. So you may have to unmute for this one and tell me, why is this mean that we got, this 31.4 that we obtained? Why is the value of the mean that we got only an estimate of the true value? I'm going to pause and let you think and tell me.
So Mrs. Thomas, we can see here that explanation is clearly a part of the new, well, it was never new, but explanation comes in the CSEC exams. So when we ask them to explain their thinking, it is something we want them to practice, because when they see terms like this, they'll understand it. It will flow. It will become a natural part of them answering a question, wanting to say the why they're doing what they're doing.
Exactly. So does anyone have a response for me? I know we mentioned it this morning, not true, Mrs. Edwards?
We did, but just to let them understand, we're asking you, why is this value of 31.4 only an estimate of the true value? Why is this an estimation?
Well, but it's the frequency. All right, so I think, so the formula again, right? I think it's the frequency times midpoint divided by the sum of frequency, right?
Right.
Right.
Mm-hmm.
So
Right.
I think it would be an estimate because of the
Just take your time.
Well, I was wondering if I should say it's because of the midpoint. So like the midpoint aren't the exact. I don't remember, Miss Samson.
You're actually on the right track.
Yes,
you are on the
you
right track.
are.
Okay, you are on the right track. Don't be nervous.
Okay.
Yes, indeed. Yes, because remember this morning we said, so we know that there are 8 scores in this case. It wasn't the same question, but the same principle is there. In this case, we had 8 scores, and the scores were, it could have been 0, 1, 2, 3, all the way up to 9. We're not sure what the exact scores were. So what we have when we use our midpoint is we're actually estimating or giving an average to say, all right, let's say that it's all of them is 4.5. We know that's not the case, right? So as you rightly said, because of the use of the midpoint, then what we have here is really just an estimate. Awesome. And I see Mrs. Cameron Edwards giving you the clap hand reaction. Wonderful.
Thank you.
Because I don't think I remember David being on this morning. So
Well,
I'm smiling. So that's good. Very good.
all right. All right, let's continue. All right, so this one we may have to spend a little bit of time on, not a lot. So in D, we're told that in order to qualify for the next round of the competition, a student must score at least 40 points. At least 40 points. What does that mean? Before I even get to what they're asking us about in the next part, what does it mean? At least 40 points.
The least him can score 40, no lower than 40.
All right, so can he score 40?
Yes, miss.
All right, or
41 up, I cannot score lower than 40.
all right, wonderful. And I see Dixon in the chat saying 40 or more. Great. So where on my table, which class intervals will be my focus for this question? I'm looking for students who score, or in order for them to qualify, they must score at least 40 points. Where would I look to find those students?
Down on the bottom, I say 40 to 49.
All right, only those from 40 to 49 will qualify?
And 50 to 59.
Oh, okay. So remember we said 40 or more. That means anything above 40. In this case, the highest score would have been between 50 to 59. We don't know what the raw data said. So that's all we know. Awesome. So let's look at the question now. It says, what is the probability that a student selected at random qualifies for the next round? Now, we didn't mention the word probability at all this morning, but we want to spend a little time and talk about it right here. So when we talk about probability, we're talking about the chance of something happening. So if there is an event that can never happen, what do you think the probability would be? Just to check.
0%, 0.
Zero. All right.
Okay.
All right. What about if an event must happen?
100%. Yeah.
I'm seeing you're using percentage, and that's what I wanted to.
All right, go ahead, Miss Edwards. Go ahead.
So when we talk about probability, we're talking about something. If something isn't impossible and it will never happen, then we use 0 because probability is represented as a fraction. So, and if we're looking at an event that will never happen, then that impossible event would be 0. And if we're looking at something that is a surety, something that must happen, then it would be represented by 1. So all the other possibilities then would be a proper fraction. All right. So even though we're not looking at fraction today, we just want to also, since the discussion went that way, explain what that is. All right. So when something is impossible, it's a 0. And if it's a sure thing, then it's 100. So hopefully I would have cleared that up for everybody.
Right. So if it's impossible, it's 0. If it's must happen, it's 1. And anywhere in between, we know would be our proper fractions or our decimals, 0 point something. Coming to the answer, sweetheart, who is asking what's the answer? Let's see. So first of all, if we're going to be talking about probability, we must first identify how many students meet this criteria.
Right.
So how many students scored at least 40? So let's look at our table and see if we can figure that out. And then we talk about how we get the probability. How many students?
That would be 20. right? Well,
32.
I'm seeing Kelly saying 32, yes. How did you get the 32? Remember, we always ask you why, how, explain.
Is because in the frequency table between 40 and 49 is 20 children, and in the 50 to 59 is 12. So I just add up them to then get 32.
All right, Kelly supporting what you're saying, and so is
It's
Esther.
Kayla, not Kelly, it's Kayla.
Kayla
Oh.
is talking, but Kelly is typing in the chat. I know, Miss McCleary, you're Kayla McCleary, but Kellyanne is supporting. Kelly is supporting you in the chat.
In the chat, right?
Yeah.
I can move forward to the next slide, Mrs. Edwards, so we can actually see now what happens with the probability. Now, if you look at the bottom of your screen, you will see now, remember, because our probability lies between 0 and 1, clearly in this case, it can't be 0 because we do have some students who meet the criteria. It cannot be 1 because not everybody qualifies based on the condition that was given, all right? So clearly our probability is going to be some proper fraction, right? So we need to figure out what that is. So having found the 32, if we, and this is a common error, if we just put down the 32 like that, we really have not given the probability. What we have stated is how many students meet the requirements, or in other words, the number of favorable outcomes, as you would see it on your screen. So we need to now remember that this must be divided by the total number of possible outcomes. In other words, what's the total number of students that we have that we could have picked from? Okay, how many? What's the total possible outcome? Who can tell me? And it popped
100.
up for a little bit. How many?
100.
100. Beautiful. So my probability then for this question, the probability that that student selected at random gets a score of 40 or more would be 32 out of 100. I'd rather if you write it as a decimal or a fraction, so you can say 0.32.
And I
Right.
want to also add, students, sometimes a question like this may value 2 or 3 marks. And the students are not sure what to write because in your mind you're saying, wow, 2 marks a lot. No, I want you to see how we are using our symbols and how we are representing the information. So let's say you did not have the part in blue, which says the probability, and then we are looking at the expected outcome. But let's say you are taking it from the second line. We want you to practice, because even when you're looking at the overall exam, there are, sometimes people will have A profile, B profile, C profile. We want you to be clear in your explanation. Don't just write 0.32 or 32 hundredths. We want you to show us your thinking and spend some time. And guess what, students? You see, if you practice this, when it comes to exam, it will be a natural. Even if the question is 1 mark and just ask you to write down something, you're writing down your thinking. We're spending the time today in the tutorial to guide you as how to make sure you have your math sentences, modeling, draw where necessary, explain, put in equations. So you notice again the probability, which speaks to what? Greater than or equal to 40. It gives us an indication that you know what you're doing. So guess what? Mrs. Wonder Thomas, if they even come down here and they had this, or there was some error in how you were now writing your final answer, because of how you are explaining yourself, we are picking up that you know what you're saying. All right, I saw that someone raised their hand. I don't know if it was a question, and then we can move on to the next part. Someone had their hand up.
It was lowered. I'm not sure if it was an error.
Okay, all right, so let's move on. Can we move on?
Yes, we can.
Okay.
All right, so we're at question 3. the cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150 different vehicles is shown below. So when we looked at a question this morning, Mrs. Edwards, right at the very end of the session, we spoke about cumulative frequency, and we actually completed that column. But here we're seeing that for this question, our cumulative frequency column has already been completed. And you would have mentioned this morning that the cumulative frequency is what we would call in quotation a running total. All right. There we go. So the cumulative frequency, for those who may have missed it this morning, tells the total of a frequency and all frequencies so far in the frequency distribution. That's why we call it a running total. So we keep on adding each time, right? So the things are accumulating. All right, so notice in the very last row, our final cumulative frequency, 150, actually corresponds with the total number of vehicles that were in this data set. All right, so let's see what we're asked.
Hello, Miss.
Yes.
Yes, so just to jog my memory, it was like, so the cumulative frequency is like 24 plus 59 gives you 101. No?
No, it's
No. So let's clarify. So if we had
we're unable to put a mark on the screen. Are you able to annotate? I'm not seeing. I was looking earlier. Okay.
I don't know if you can use your pencil, your pen from PowerPoint itself. If not, then.
No, I'm unable to. That's okay.
So what's happening here for the students who asked the question?
All right, so for the students who asked the question, no, this morning we actually showed you that we're starting with the first frequency. So the frequency that you're seeing here, the cumulative frequency, is already a running total. So for us to know what the frequency for 21 to 30 would be, we would have to subtract 24 from 59, because remember, no, it would be 24 plus something that is giving us the 59. All right, so in answering David's question, these are not the frequency. It was already added for you. And this is another, this is something, because you want to pull from the report. We know that you're always used to doing the totals. Now, here is a question that already did the total for you and is testing your understanding of cumulative frequency. So all of these totals have already been added, David.
So Mrs. Edwards, let's do some interpretation then. So that 24 is saying to me that there were 24 vehicles that needed 11 to 20 liters of petrol. That
or if we want to add the boundary, we could say 20.5 liters and below.
And below, all right, fine. That 59 is not speaking only to 21 to 30, not only that class interval, it is speaking to all the intervals before. So that 59 is saying to me that there were 59 vehicles that needed 30, and as Miss said, 30.5, since we're doing boundaries, liters of petrol, right? So it would have accounted for all the vehicles before. So the addition has already been done for you. So be careful with the interpretation. It is not saying 59 vehicles needed 21 to 30 liters of petrol. No, that 59 is speaking to all the way from 11 all the way up to 30 liters. So when you get to the third row that speaks to 101 as the cumulative frequency, it is saying that 101 vehicles needed 40 or less liters of petrol. So it accounts for everything that came before. Okay. All right, and that is why when you get to the end of the cumulative frequency column, you would have accounted for everybody And that's why that 150 is there. Does that make sense? Person who asked the question didn't get you.
Yes, yes, miss. Sure.
What about the other students? What about the others of you? And the interesting thing is that students, because we only we understand cumulative frequency to be added, we tend to have a challenge to break it down. What could help you if you were to do your own subtraction and then you are able to come up with the individual frequencies?
Right, Mrs. Edwards, that sounds like you're preempting the question. Let's see what we're
Okay.
asked.
All right,
I do
let's
believe
go.
we're asked something along that line. So let's see if they can get what's happening. I think it's probably the other part of the question.
Okay, so David
All
and
right.
others are getting there.
We are getting there. So this first part is asking us to determine the lower class boundary. By this time, we're all experts at this. So I need to see the chat blowing up with the responses for this question. The lower class boundary for the class interval 21 to 30. All right, I see David, but I want the chat blowing up. What's happening?
It's not blowing up. Come on, Kelly.
It's
Come
not
on,
blowing
Kayla.
up.
Come on, Dexter. Come on, Bailey. All of you start to tell us that you know something. We did this morning.
And I'm here boasting, you know, that they're experts. I know they are. The fingers probably just not moving as fast. All right, see there? Rakita coming on board. All right. So indeed, that would be 20.5. So we're not gonna spend long here because we would have done many questions speaking to class boundary. All right, let's see what's next. Class width is coming up again. And I know that we are experts at this part. So let me hear, what is the class width for that same class? I mean, it would be the same for the others based on the data, but what's the class width? All right, and Kelly is out of the blocks with her 10. Awesome. Awesome, Dexter, great. So we would have discussed this in a previous question as well. All right, wonderful. Now here is it. Now here is it. How many vehicles were recorded in the class 31 to 40? I know before our discussion, Mrs. Edwards, and before the questions were asked, some persons would have given a particular answer. I don't want to say it yet in case anybody didn't hear. So let's see. How many vehicles were recorded in the class 31 to 40? I need the response and, of course, the how or the why. Who's gonna tell us? Seems as if they're malicious. Miss Edwards.
Probably.
Is it, are you sure? How many vehicles were recorded in the class 31 to 40?
Okay, somebody's in the chat. Okay, it's.
Let's talk about this. So remember now, let's see if we can identify what's happening. And you know, you mentioned it earlier, Mrs. Edwards.
We
mentioned
did.
it earlier, yes, but let's see. All right, so we have 24 vehicles. Let's follow our table now. We have 24 vehicles that needed, or that's in the interval, let's just keep it simple, 11 to 20, all right? Now, this 59, we said, account for everybody from 11 all the way up to 30. So can anybody tell me how many would have been in that second interval? The 21 to 30. So we're bearing in mind that there are 24 vehicles that fall in the 11 to 20 category. And we have 59 vehicles so far.
All right, I'm seeing where David had 18. How did you get 18?
Oh my lord. Because all right, so that doesn't make sense. All right. Oh, wait. Let me come back, please. Let me come back. One moment.
Okay, no problem. All right. I'm seeing Tatiana put in 101.
What does the 101 represent? Only the 31 to 40?
Is it 42? Oh my lord.
All right, David. All right.
How did you get that 42?
What I did was subtract.
No, you're going David, or we're going to allow Kelly to talk, because Kelly also
All
typed
right.
42.
I want Kelly.
David is gladly giving way to Kelly. All right, go ahead, Kelly.
Kelly, how did you get the 42? Nothing? Anybody else backing up
Right.
what Kelly
I
is
think
saying?
I just answered it. So what I did was subtract 59 from 101 because I remember like you're saying that 24, so 24 is all the liters, right? From 11 to 20, right? And then from 11 to 30, that's 59, right? So going from 11 to 30 now, right? We are 59 liters now, right? And then because it stops right there, and then because as you move up, right, to 31 to 40 now, adding more volume of liters, you would get 101, right, as you move up. But then, so that means that you'd have to subtract like the volumes from 11 to 30 from the total amount, right? That would be 101, like moving from 11 to 40. And then you'd actually get how many leave.
Which is what? 42? That's what, okay.
Right, I follow your reasoning. Just remember though that the cumulative frequency, not speaking to the volume, but it's speaking to how many vehicles needed that amount of liters. Yeah, but I get what you're saying. All right, wonderful. So that 101, okay, the difference from the frequency of the class interval 11 to 20 and 21 to 30. Okay. All right. So what was said makes perfect sense, because if each time I started with 24 and then something was added and I got to 59. So I could use that to figure how many vehicles would be in the second class interval. Then thereafter, after 59, some more vehicles were added. We're not sure how many, but we ended up with 101. And the question is really asking us how many were added. Pretty much what the young man said earlier. So yes, we would need to do a subtraction here to figure out how many vehicles would be just for that single class interval. All right, so notice this one kind of flipped the script on you. So you're accustomed to, adding and completing the frequency table or the column. And this time it's given to you and you have to work back to the frequency. All right, so remember now, and you can think about it, think about your operations. To get the cumulative frequency, you would have been adding each time. Therefore, if I want to get back to the frequency, then I must be performing some subtraction. Wouldn't that make sense, Mrs. Cameron Edwards?
I'm sitting here and I'm smiling. I'm saying yes, exactly.
Yes. So you can think about it from various angles. All right. Wonderful. I knew we would spend some time right here. So no harm done. Are we clear though on why this is 42?
Yes, miss.
All right, awesome.
I hope we're writing this down and we're doing screenshots, or as usual, remember to go and like and subscribe and go back to the YouTube channel. Right, we're gonna move on to the next
Miss,
question. Okay, here.
Someone
Miss, what is
said
the
miss.
usage time?
Listen, also, never want to cut them miss, but even though you passed already, so I'm there still figure out how to get the answer, miss. A.
What was
You do
A
the,
again? I was here.
for the class 21 to 30, determine the low class boundary and class width.
Oh,
But me
remember
understand
that
if you understand.
your lower class boundary would be 0.5 less than the limit. So for 21 to 30, our lower limit is 21. So we need to step it back 0.5. In other words, subtract 0.5 from that 21. That's how we end up with 20.5. All right, remember the boundary extends 0.5 below the lower limit if you're looking for lower boundary, and if you're looking for upper boundary, it's 0.5 more than the upper limit. Okay?
You know, me there say I do this. Me there say
What were you doing? Tell us.
There are thing about the 24 and the 59. We take away from this the answer when I get when I find when I the lower boundary feet miss, but my analysis say that wrong. So I try to figure out it is. But
How did we get this? Right.
But the most important question though, are you clear now so that you don't make any error when the exam comes? Are you clear on it?
Yes, miss.
Right, awesome. And for the class width, remember, we can subtract 2 consecutive limits, lower limits. So you could have done 21, subtract 11, which should be the lower limits for the first 2 intervals. Or you could take the upper limits too. You could have said 30, subtract 20. Either way, you would still get the class width. All right?
Yes, miss. Yes, miss.
I think somebody had asked if it was 9 at one point, and I'm hoping that this subtraction also helped. All right, so this morning we had some ways how you could actually do the subtraction. You can look back at those. So the person who had typed in the chat, it's not 9 but 10. All right, so we can move on to this part of the question now.
All right, so this is another probability. So let's see if what we learned from the previous question. Now, in this case, a vehicle is chosen at random, clearly from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5 liters? And you know, my usual question is going to be where on the table? Which class interval do I need to focus on if I want to find vehicles that required or needed more than 50.5 liters of petrol? Which class interval am I looking at?
Miss, from 51 to 60.
All right, 51 to 60. So I'm looking right in that category. Now, based on what we said about probability, remember, it's the number of favorable outcomes over the number, or divided by the number of possible, or the total number of possible outcomes. Let me ask it now. What's the total number of possible outcomes for this question?
Yes, please repeat.
What would be the total number of possible outcomes?
I'm working on it.
21.
You sure? Remember our total number of possible outcomes. All right, someone typing in the chat. The total number of possible outcomes speaks to how many vehicles in this case you have to choose from. What's the total number of vehicles that we have in this question? How many we have? And I see your answer, Dexton, in the chat. How many?
150.
Yes, man, 150. A little bit low, but yes, 150. So therefore, when I'm looking at the probability, I'm expecting to see some value, don't know what it is yet, being divided by 150. So remember we said number of favorable. What does favorable mean? What it is that we want. So let's see again. We're looking for vehicles that want more than 50.5 liters to fill its tank. How many vehicles need this amount of petrol? How many vehicles need this amount of petrol? So remember, it cannot be 150 because 150 is every single vehicle in the data set. All right.
21.
All right. So 21 vehicles would fall in this category. So same as how we figured out how many vehicles were in the range for 31 to 40 liters of petrol. It's the same idea, only that this time we're looking at probability. And so we need to have that written as a fraction. Now, Mrs. Edwards, I assume you were going to chime in right here and speak to the inequality, but let's look at this one. Notice in this case, it said more than 50.5. So 50.5, not in it. More than. Good. So you notice the R equal to part is missing from that sign. So even though we're not looking at inequalities per se, it does pop up right here. And so we have to point it out. David, you may want to double check that calculation. Remember, it's not 21 being divided by 100. It's 21 being divided by 150.
50. So and I was about to point that out. There are two things I wanted to point out in this question. Remember earlier when we were doing the seedlings, we said, do we need to start from 1? This table did not start at 1. It started at 11. Same interval of 10. However, and again, you brought out the inequality. And not because we're saying probability. There are so many times they link the word probability with 100. And we have to be careful. Notice what the total possible outcome would be. It's 150 different vehicles we're looking at. So we are looking at the number of vehicles, the favorable outcome. And in this case, it was 21. So students will have to be very careful. And that's a time. So I'm still seeing. So when we actually divide this, what are we getting? I didn't break it down.
0.14.
Okay.
Okay. But it's okay to leave it as a fraction.
As a fraction.
Just to be clear, right? It's quite fine. All right.
So Miss, is it after the 129?
Yes. Okay, before I should have said this, I should have allowed you to ask me a little bit more. What do you think, or why you're thinking it would not be 129? Where would you want to start from?
I'm not sure, but I'm trying to figure out all the 129 after you, that's why.
So remember, based on how we interpret the cumulative frequency, those 129 vehicles, they want 50 liters or less. As a matter of fact, they want 50.5 liters or less, right? Based on the boundary. So what we're saying is out of the set of vehicles that we want, we don't want that 129 because they don't meet the criteria. The 129 vehicles, they are for the persons who wanted between 10.5 all the way up to 50.5. The question says we want those who want more than 50.5. So we don't want those 129 vehicles. So we have to take them out and see those who are left would be the ones that require more than 50.5. So that's, I'm trying to express it another way. So you see what's happening. Is it any clearer?
Yes, yes.
Awesome.
Yes.
All right, we can move to the next question. I do believe we are approaching our final question, but there are some things that we need to discuss a little before. Go ahead, Mrs. Edwards. Oh, there was another part. Okay. No, man, go back. This one is important. So the cumulative frequency distribution, same one that we've been looking at. This is the final part of question 3. Now, Byron estimates the median amount of petrol to be 43.5 liters. Explain, we're seeing another explanation question, Mrs. Edwards. Explain why Byron's estimate is incorrect. So this morning we talked about the median being the middle value of a sorted data set. Clearly, based on the frequency table, the data has already been sorted because we're seeing it running from least, which is 11 liters, all the way up to 60 liters. So where would I find the middle? When I speak about the 150 different vehicles, where would I find the middle of that data set?
Means you have to go take away first and you have to go set them in an order. Right?
So let's say they have been arranged in order and there are 150 of them. And they're telling us how many liters of petrol they need. Where would I find the middle value? So I've written down all 150 values. Where would I find the middle one? And it's already arranged. Where would I find the middle?
Yes. Would you like look at the like the median class?
All right. So if we're talking about median class, we still have to speak about where would we find the middle, because the median is speaking to the middle. So where?
One moment.
So if I have 150 numbers written down in order and I want to find the middle, which position, which location would the middle be?
101, 100 or 100.
Yeah, sure.
Miss,
It's in between 31 and 40, right?
I don't want, no, not the class yet, you know. I just want to know the location in terms of if it's the 5th number, would it be the 6th number? Would it be the 20th number?
Oh, the 3rd number.
Would it be the 100th number? Would it be the 75th number? Which of them would it be? If we have 150. Yes.
I think it would be the 70. Well,
75th.
Not exactly the 75th. I think because it's an even number, Miss, 150. You would put the 70. You would use the 75th number and the 76th number, right?
All right.
Then divide.
All right. Okay, so we have 150 numbers, and we're saying the halfway mark would be halfway between the 75th and the 76th number. Great. So we need to find which class interval that falls in. I heard some answers coming. Some persons were giving multiple classes in the chat. So I want to ensure that we clear that up. So my first 24 cars are in my first class interval. Have I reached the middle of the data as yet?
No, Miss.
No.
No. All right. Then some more vehicles. We got the information from them, and we are now at 59 vehicles that have given us information. Have we found the middle? Are we there yet?
No.
No, Miss.
No. All right. Then we got some more information from some other drivers telling us how much petrol they need to fill the tank. And now we are at 101 vehicle. Have we reached the middle yet?
Yes, Miss.
Yes.
Yes, we have reached and passed it. Not true. Good. So which interval would the middle have been? Would it be 21 to 30 or 31 to 40?
31 to 40.
Awesome. So I see persons correcting themselves in the chat. I see persons correcting themselves in the chat. Awesome. So let's look at Byron's estimate. Where did Byron's estimate come from? Which class interval?
Miss 40.
That'll be I think this will be
41 to 50.
It coming from 41 to 50. Is that where we found the median? Did we find the median?
31 to 50, 31 to 40.
Aha, that's where we found our median. So
Yeah,
is
Miss,
Byron
and the
correct?
class from me that about Miss the 5.5 Miss from the class. I don't know the
I
last.
think that would be class 21 to 30 because because it's a 59, so that means a 43.5 liters would fall in between 24 and 59.
All right, so hold on, backtrack, wait, let's settle. So let's close our mics and let's listen again because we have to get this interpretation correct. So let's speak to it now. In our discussion just now, we know that because we have 150 values in our data, we know that halfway in that would be 75 or the 75th and the 76th number. So I want to find the middle. So it's halfway between those. Now, I need to use my cumulative frequency to determine at what point, when do I get to that 75th score? Not score, sorry. 75th number. It's not score in this case, right?
75th
no,
car.
We have to use our cumulative frequency. Now, we already established that from the first class interval, there were only 24 cars, and so we have not yet reached the middle. Some more cars were added, and we got to 59 vehicles. We still don't reach the middle. By the time we added another set of vehicles, we got to 101 vehicles. And we said, oh, but we passed the 75th one already, passed the 76th one already. We would have passed those vehicles and they would be in the class 31 to 40. So whatever my median is, don't know what it is yet, and I can't tell what it is from what we have. But what I know is that the median must be between 31 to 40. Now, look at what Byron gave as his median. Would he be correct? He's saying the median is 43.5 liters. Would that be correct? That's the question.
No.
No, he wouldn't be, because he would be outside of the median class. We just found the median class to be 31 to 40. So any median that I am going to get must be somewhere between 31 to 40. Anywhere outside of that would be outside of the median class. Are you getting what I'm saying?
Yes, please.
Good. So I knew again that this one would be a little bit tricky. So you may want to watch this again after, just to ensure that you assimilate the information. All right. So I'm going to repeat for the last time and then we move on. So remember now, we have 150 as our total, which means our median is going to be halfway between. That is between the 75th and the 76th. When I look at my cumulative frequencies, after the first 24 persons gave their information, I haven't reached the middle yet. Some more gave their information, and we got up to 59 vehicles telling us their estimates of petrol needed. Still don't reach the middle yet. But when I put in the other numbers from 31 to 40, I have passed the middle. It means the middle would have been passed somewhere in the class interval 31 to 40. And so Brian's estimate is too high, too much. He's in the wrong class interval. All right, that's where I'm leaving it. Miss Harris, you wanted to say something, or?
No, I was just responding to
okay.
Dexter had said that the 43.5 was smaller. So I was just helping to realize it wouldn't be smaller, but it's in the class that is actually above the median.
Okay,
so it would be smaller. The lower class interval would have been a smaller value below a number of cars lower than the median. But go right ahead, we don't are against the clock.
Okay. All right, so we are approaching our final question for the afternoon. But just before we get into it, because there are some things that are asked of us that we may not have known yet. And these are three of the terms that will come up: the quartile, the interquartile range, and what's the other one, Miss Edwards? I'm not seeing it popping up. I know there were three, thank you. The semi-interquartile range. My brain just froze. All right, so these are three terms that will come up as we discuss cumulative frequency, and in particular, the question that we're going to be discussing. So let's talk a little bit about what the quartile is. And if you think about it, it starts to sound like quarter. And I know that we spoke a little about fractions earlier. So the quartile, right? When we identify the quartile, we are actually cutting up the data, for want of a better phrase, sectioning the data into 4 equal parts, right? So the quartile is really a value. It's that value that sectionalizes whether you're cutting off the first or the lower quarter, in which case that would be our Q1, or we may be cutting it right in the middle, which is our median. That's known as our Q2 or our second quartile. And it could be that we're cutting off the very top set of values, in which case we would be at our upper quartile or Q3. So note these arrows here. Note the lower quartile is Q1, and it's pretty much that value that cuts off the quarter at the lower end. Then our median, we know is in the middle, and it's basically cutting off the lower half. Of course, it's half, so you have the upper part too. And then we have our upper quartile, which is that value that pretty much cuts off the upper quarter of the data. So let's look at it. This is raw data, and in this case, we have 11 values. Hold on, Miss Cameron. We had 11 values. Notice our median would be the 6th value, because it separates 5 values on the left, 5 values on the right. So my median is pretty easy to identify. My lower quartile, those 5 values that are in the lower portion now, I need to find the middle of that. So if we look there, the middle would be the 3rd value. Now, for the upper quartile, those 5 values to the right, I also need to find the middle, in which case, or in this case, it is 9. Good, so that's what we mean when we talk about the quartiles. You may go ahead now, Miss Edwards. All right, so we also have what is called the interquartile range. And notice that word range is coming back. So we talked about range this morning being the difference between the highest and lowest observation, whether it's scores, lengths, weights, whatever it is that we're observing. Now, the interquartile range will take on a similar approach, but in this case, it's the difference between the upper and the lower quartiles. So we have not gone to the very extreme to say the highest and the lowest values we're subtracting. No, we're taking those values at the upper and lower quartiles and subtracting them. And you'll see what that looks like in a minute, all right? So it is said that this is a better measure of spread because it really focuses on the data that is, you know, pretty much in the middle portion of the spread, all right? And so it's not subject to extreme values. Now let's look at this one. Same example. Are we seeing our upper quartile? What's our upper quartile value? Someone type it in the chat quickly. What's our upper quartile for this data set? Nine, beautiful. What's our lower quartile? 3, awesome. So if I want to find the interquartile range, and I just said it's the difference between the upper quartile and the lower quartile, what would I get for my answer and how? I just want to ensure you get the how. So I see 6 coming up in the chat, but you're gonna have to tell me how we got that 6. What did we do? What did we take from what? All right, so Rakita is on the ball with that response. It would be 9 subtract 3. Beautiful. All right. And the last term was the semi-interquartile range. And I have a question. When you hear semi, what comes to your mind? We know about semicircle, you know. What comes to mind?
Half.
Yeah.
All right, I hear half and I see half blowing up the chat. Awesome. So then my semi-interquartile range, and it was on screen, would be half of my interquartile range. So all of those words, that's pretty much what it's saying. It's a half of the interquartile range. Go ahead.
So Miss, so since the interquartile range was 6, that means it would be 3.
Awesome. Perfect. Nice. Beautiful. There you go. All right. So that's pretty much just some information that will help us as we answer the very last question for our session this afternoon. So question 4. The table below shows how many minutes, the minutes taken by all students to complete a science experiment were recorded and grouped. All right, so we have, again, grouped data. We have the frequency this time. So this is more like what we're accustomed to. Probably that's why question 3 gave a little bit more trouble than the others. But as I say, you may want to go back and watch our discussion again, just to ensure you get it. But this one is similar to what we're accustomed to. So we have our frequency and we have our cumulative frequency column, which has been started for us. I'm suspecting they may ask us to finish it. Let's see. What do you know? Part A, complete the cumulative frequency column in the table. So that's 1. And 2, on grid paper, using a scale of 1 centimeter to represent 5 minutes on the x-axis and 1 centimeter to represent 5 students on the y-axis. Draw a cumulative frequency curve to represent the information in the table. I know yesterday's session spoke about coordinate geometry. So just in case you may have any issues with scaling and so on, you may want to revert to some of those ideas. All right, so let's see if we can complete our cumulative frequency column. Now, this one is what we're accustomed to. So who will tell me what would be in the third class interval? What would be the cumulative frequency there?
Can we just ask them how we got 3 so that they see?
The 1 plus
All right,
2.
go ahead.
The 1 plus 2. All right, fine. I'm not sure if Rakita was answering my question because I'm seeing
No, I
Rakita
don't-
subtracting.
No, I think he's referring to the class interval 11 to 15, but he's thinking the cumulative would be 6. So I want to know, at least that's what I'm thinking he's saying. You can let me know if that's what you're saying. But would it be 6 though? So let's check what would be the cumulative frequency. That's what you're saying, okay. But would it be 6? Because we had 1 student who took 1 to 5 minutes. We had 2 students who took 6 to 10 minutes. And we had 5 students who took 11 to 15 minutes.
Miss, it would be 8.
It would be 8. It would be 8. So what would we adding?
Okay, Miss Rakita. All right. So
what would we be adding to get 8?
The 5 plus 3.
All right, awesome.
And we don't want to miss what was said a while ago. So again, students, this is now the flip of a question. This is not asking us to subtract. So we don't have the cumulative frequency. We are now being asked to populate the running total. And we have to be very careful. Yeah, understand? So that's why I say when you have a table to complete, find out first how they start the table. So we have 1, and we realize that's the first frequency. Then we had 3. What did I do to get 3? Those are the questions you need to ask yourself so you can start seeing a pattern. And someone did say when I add 1 and 2, which is the next frequency for 6 to 10, we'll get 3. And that's how the discussion will go in. So you know that we're completing the running total. All right?
Definitely. Right. So we should be able to populate the rest. What would come next? 8 would add to 7, good, to give us 15, followed by what
25.
would be next? All right, 25, in which 15 is now being added to 10. Awesome. And you can just finish the rest and tell us. All right. Notice now, let me ask you, how many students participated in this science experiment?
50.
50, how you know that? Somebody said
Because
50.
you're gonna add up the number of students who completed the frequency, and you're gonna get 50.
Do I need to do that again though?
Or you
Where
can
else?
look on the cumulative frequency part.
Where in the cumulative frequency column? Where would I look to find the total?
The last part.
The very last value. Thank you. Good. So remember now, if it was stated in the beginning of the question, it would actually give you a clue. So you could also use that to double check if your cumulative frequency column was completed properly. In this case, it wasn't stated how many students. So you just have to be careful and ensure that you're adding properly and get to the correct total. Now for the drawing of the cumulative frequency curve. So in the very brief look at it this morning, Miss Edwards, we would have seen a cumulative frequency curve that used the upper boundaries to plot. In this case, we're looking at one that used the upper limit. Remember, you had the option to use either one, so it really doesn't matter. All right. So what are we mapping here really? Let's look at my upper class limit for the first class is 5. And so I'm matching that with 1. So let's bring up our labels. Remember now our time will be on the horizontal axis and our cumulative frequency, or the number of students, will be on our vertical axis. So the time that we're looking for 5, and it's supposed to match with 1 on the cumulative frequency axis. All right, and that should pop in, right? And 10 will match with 3, and so on. 15 will match with 8, all the way up till we get to 40, matching with 50. And then remember now we use a smooth curve to connect our dots. Awesome. So this is what your cumulative frequency curve should look like. Don't know if you got a chance to reach to this question in the break, but if you did, you can make a comparison between what we have on screen and what you did for the question.
Miss, so the graph should be like, it should be a smooth curve line, like no edges or like vertex or stuff like.
You don't use a ruler, you don't just
Right.
connect one dot after the other. It's something with practice. So you can turn around the graph paper and just, even if you have to connect them one at a time, you can connect them in such a way that it's a smooth. So you don't use a ruler, it's not a line graph where you're connecting with the ruler straight. So it's a curve, like if we were to construct any of our parabolas or any one of those, it's a nice smooth curve.
Right. So we're winding down. Let's see what we're asked.
And just before you jump off, students, we have some tips we want to share, these statistics. So we're going to go through as quickly as possible to get to those.
We'll definitely be finished within our time. All right, so we're asked to use the graph to estimate. Notice the terms coming up now: median, interquartile range. We spoke about those things earlier, and it was specifically for this part of the question. So let's see how we can estimate these things from the graph. So we need the median time taken to complete the experiment, the interquartile range, and we also need that probability. Go back, please. Let me see what it said. The probability that a student chosen at random took 30 minutes or less to complete the experiment. All right, so let's tackle the median. All right, so remember now, we had 50 students, all right, that recorded their times. So if I were to write out the 50 times, where would the and I keep asking this, where would the median fall? Would it be the first one, the second one, the 20th one? Where would the median be located if we have 50 numbers written down in order? Anyone?
And in what position would it lie?
The 25th.
Yeah, the 25th and 26th.
All right,
Okay.
so it will be halfway between the 25th and the 26th. Good. So if I want to find that location, where would I be looking on my curve? At the cumulative frequency or at the time? This will be interesting. Okay.
The time, all right? No, the cumulative frequency, miss.
Okay, and I deliberately asked that, you know, I deliberately asked that because I've been stressing from way back when, from the table days, that it's the cumulative frequency that helps us to find the location. Good. So when it comes to the graph, it's the same idea. All right, so we look at our cumulative frequency and identify the location where we said the median would be. Notice I'm not really dead on the 25, I'm a little above, because we did say it's half between the 25th and 26th, but it's an estimate that we're gonna get here anyway. So let's see what we have. So coincidentally, our median happens to be 25 minutes. Notice though, it's gonna circle it, so you see exactly which 25 we are reading from. So we found the 25th, halfway between the 25th and the 26th. Location from the cumulative frequency. We did our dotted line coming right to the curve, and then we read off the value from the time. Notice it said the median time taken. So my answer must be in terms of time, which in this case is minutes. We can move on, Mrs. Edwards. The interquartile range. So earlier we talked about upper quartile, lower quartile. So where do you think we would find our lower quartile? In which location? So our median is somewhere between the 25th, 26th, halfway between 25th, 26th observation. Where would my lower quartile be?
Yes, I think it would be like, let's say 12.5.
Yeah, we can work with that. Right in that region there, no? All right. Yes, so again, we read from the cumulative frequency because we find the location where we think it should be, and then we read off the time, all right? So in this case, our Q1 or our lower quartile would be approximately 18.5 minutes. Notice the approximation sign that is used. So it's not exact. All right, what about my Q3? And if we're talking location, about 3/4 way into the data.
That's
all
like,
right.
what is that? 26, 7, 8, 9, 29 minutes? I'm not sure.
Well,
probably not. Okay.
Yeah, no. Right there. That would be our estimate. Very good reading. Excellent. Wonderful. So what did we say was the interquartile range again? That word range coming up again. What did we say? How do we find it? Are we finished?
Okay, miss. So the interquartile range is the difference between the upper quartile and the lower quartile.
All right. So what do I need to do here then?
Minus 18.5, which would be the lower quartile, from the upper quartile, 29.
Right. Awesome sauce. Good. Great. All right. And so our interquartile range would be 10, approximately 10.5. Now, this question didn't ask about semi-interquartile range, but suppose I wanted that. What would I do with this 10.5 that I got here? 10.5 minutes. What would I do to get my semi-interquartile range?
Okay, miss. So, wow. Like, all right. Does anyone else? All right, I'll go make somebody else share, miss.
Okay. Anyone else wants to say something? Or maybe you're shy and you want to type it in the chat. But we talked about the semi-interquartile range. The question didn't ask it now, but I just want to make sure you get it. How would I find the semi-interquartile range? Knowing that my interquartile range is approximately 10.5 minutes. What could I do?
So find the difference between the first and the third quartile.
All right, so we have done that already and we got 10.5, but I want the semi-interquartile. So 10.5 is my interquartile range, but I want the semi. What did we say about semi earlier? We spoke about what semi mean. All right, and Dexter is typing in the chat. So if we were asked by chance for the semi-interquartile range for this set of data, we would just take that 10.5 minutes and divide it by 2. Awesome. What? I even getting the answer. All right, Dexter. Wonderful. Thank you. And finally, before we take you through the tips, which will be about 5 minutes, we're asked to estimate the probability that a student chosen at random took 30 minutes or less to complete the experiment. So hold on now, wait. Where am I to look for this 30? Am I looking at the cumulative frequency or am I looking at time? Based on the question, I'm trying to find some students who took 30 minutes or less to complete the experiment. So I've been given 30 minutes. Where do I look for that 30 to start doing my mapping and reading off? Somebody said cumulative. Let me read the question again. The probability. Go ahead.
Time.
All right, the probability that a student, yes, we're going to find out the student, you know, but what are we going to be using to determine the students? Chosen at random, do what? Took 30 minutes or less. So my starting point must be what I've been given, 30 minutes or less. So I need to work from time. Great. So let's see how we do that. We find 30 on our time axis. So this time we're using our broken line.
Awesome.
Vertically. Once we get to the curve, we read off our value. So how many students took 30 minutes or less?
So that would be 40.
40 students took 30 minutes or less to complete. But guess what? Is that the answer? Because it's a probability. So what will the answer be? Go ahead. Someone was speaking. Go ahead, man.
Somebody has.
For real?
Kelly. David, are you answering?
Oh,
I see.
I thought someone was answering it in the chat. So.
Well, Kelly has 40, 50. So.
All right, so let us check. What is the favorable outcome? The students who took 30 minutes or less, which is 40. Beautiful. Total number of possible outcomes. How many students are in the data set? 50. Awesome job, guys. Awesome. So at this time, Mrs. Cameron Edwards will guide you through the tips for statistics, for answering statistics questions. And that will take us to the end of our session this afternoon.
All right. Thank you very much, Mrs. Mundell Thomas. So before we go, remember to also complete our evaluation again, which will be placed in the chat. So here are some tips we want to leave with you. Pay attention to the frequency given, whether it's a cumulative or not. Pay attention to that. So we saw in the last two questions how the scripts were flipped. Sometimes you're given the running total and you have to find the frequency or questions to that, or sometimes you're given the frequency and you are then asked to compute or to calculate the cumulative frequency. 2, my second point, ensure that your total frequency is the same as the total number in the set of given data. If it is given, make sure if you're doing a running total and you should have 100, you're not at 58, or you're up more than the number. If it is not given, that's more crucial. Make sure you double check to see that you have the total frequency. The other tip I want to also leave here is the difference between two consecutive midpoint is the same as the class width. A lot of times when we're looking at the midpoint and we're saying, how do you want to complete the table without adding the say the upper and the lower limits or the intervals and dividing by 2, this is another point. If you can identify what the class width is very important. This class width came out in so many different conversations. So let us make sure that we can see that the difference between the two consecutive midpoints is the same as the class width. The cumulative frequency, in each row represents the frequency of the values for the row and all the previous values, especially the question before the last question. I believe Mrs. Thomas would have taken you through that. Look back at that question. So when you had the table, which was already completed, the cumulative frequency, it's not the frequency. It is speaking to the values and the previous values. All right, so make sure that we understand that. Read the instructions carefully. Do not just do as what was instructed. So make sure when you read the instruction carefully and do exactly what you're told to do. Use the scale given. In this example with the graph, they told you what the scale for the graph should be. You're going to be awarded a mark or two. Don't throw that away. Use appropriate solution method as instructed, whether it's calculations, the tables, the graph, and we're not leaving out the explanation. Look at how to write your math sentences. Model how we explain. Explanation doesn't mean you're writing long sentences. It might just be that you're using, say, inequalities in the sense of the probability, or to make reference. Don't miss the opportunity to get the marks there. And my final set of tips, probability ranges from 0 to 1. All right, make sure we understand that, especially in the part where the multiple choices. If you calculate probability and your answer is more than 1, it is not correct. It is incorrect. All right, so let me say this one again. Probability is a proper fraction. If something is impossible, then it is, you can light up the chat with that. If it's impossible, what's the probability? Don't see jumping out in the chat as yet? Yes, we said this so many times today, 0. And if it's impossible, it's 0. If it is something that is sure, it's 1. Then everything else is a fraction. So if you have a value that is more than 1, it is incorrect. And we would have come to the end of today's session. Join us tomorrow for another session where we are going to take you through, I believe it's trigonometry. Don't miss that session. All right. So we would have left a few tips with you as it relates to